Good morning, students.
Good morning,
Good
sir.
morning, sir.
Very,
Morning, sir.
very good morning, sir. Okay, so last class we already discussed about the boilers. Two types of boilers we already discussed. So what are those? Can you tell me? So two types of boiler we already discussed in the last class. So what are those boilers? Anyone? Amit, Amit Vegas, Amit Vegas is not there.
Yes, sir.
Uh, Two types of boiler we already discussed in the last class, right? Can you tell me which boiler we discussed? Amit, tell me.
Lancashire boiler. Lancashire boiler.
Lancashire boiler.
Lancashire boiler.
That is one. Next one. One is Lancashire boiler. One more. So one more. Tell me. So Babcock and Wilcox boiler. First one. Second one is Lancashire boiler. Okay, these are the two boilers we discussed in the last class. So once again we'll discuss, go through it. Next we'll discuss the turbines. Okay. So today's class will discuss about the turbines. So whether this PPT is visible?
Yes, sir.
Yes, sir.
Okay. So once again we'll go through the turbines. So Babcock and Wilcox boiler. So diagram is very important. Okay, diagram with explanation. Okay, so this is the drum is kept in horizontal direction, so it is also called as horizontal boiler. And water is moving naturally from lower level to higher level, so it is also called as natural circulation of boiler. Okay, so next, furnace is placed outside the boiler drum. Okay, this is furnace. So furnace is placed outside the boiler drum, so this is boiler drum. So it is called as externally fired boiler. Okay, externally fired boiler. And heat is passing outside the tube, not inside the tube. So it is called as what? Water tube boiler. Why? Because water is passing inside the tube, fire is passing outside the tube, so it is also called as fire tube, water tube boiler, not fire tube boiler, water tube boiler. Why? Because water is passing inside the tube. Okay, so next, the pressure gauge, it will indicate the pressure inside the boiler drum. Okay, next, the water level indicator, it will helps to maintain 50% water inside the boiler drum. And feed check wall, it is helps to, if the water falls below the level, it automatically this will open, and the water will be moves inside to the boiler drum. Next, this is the steam stop wall. So safety wall, this is safety wall. So if the pressure is beyond the limit, so automatically this safety wall will be open, so extra amount of steam will be escaping through this safety wall. And steam stop wall, so steam stop wall function is to, it is connected to the turbines. Okay, so what, dry steam, so here heated chamber, superheated chamber, so that here wet steam is converting into dry steam, wet steam is converting into dry steam in YouTube. So then it is moving to the turbines. So dry steam is moving to the turbine plates. Dry steam is nothing but pure form of steam. Okay, so next, blow off wall, so it is helps to improve, remove the impurities present in a boiler drum. Okay, so next, these are number of tubes. The tubes are kept in angle, some angle. Okay, maximum up to 40 degree. Okay, so next, certain 50 to 70% water will be placed inside the boiler drum with the help of feed check wall. Then that water will be moving downward through this downtake header. Okay, downtake header. Then furnace will be continuously producing the heat. That heat will be flowing throughout the pipe, so that whatever water will be present in a pipe, that will be gets into heated. And then that water will be raising from lower level to higher level. So slowly it is loses its density. So density is equal to mass by volume. So mass decreases is nothing but density decreases. So vapor density is less compared to water density. Okay, water density. Okay, so that it gains the heat, so that slowly converting into vapor form. So vapor form is nothing but steam will be moving from lower level to higher level due to density difference. Okay, then vapor form of steam is moving back to the drum. Okay, so here also it will be collected at the top of the drum. Why? Because it is having less density. Okay, so that it will be collecting in the top of the drum. So then this is called as wet steam. So wet steam is nothing but water mixed steam. Okay, it is not a pure form of steam. Wet steam, that wet steam is again goes to the U-tube. Okay, U-tube structure. Here again it will gain some amount of heat, so wet steam is converting into dry steam. Then dry steam is goes to the turbines with the help of this steam stop wall. Okay, with the help of steam stop wall. So this is buffel plate. So buffel plate is helps to distribute the heat properly throughout the pipes, throughout the pipe. This is the working principle of Babcock and Wilcox boiler. Understood? Any doubt? Any doubt here? No, right? Okay, shall I move to next boiler?
Yes, sir.
Okay. So next, Lancashire boiler. This is the structure of Lancashire boiler. So this is front view, uh, top view as well as side view. Okay, so here two pipes is passing throughout the boiler drum. Okay, two pipes. Okay, flue tubes. So tubes are passing throughout the boiler drum. Okay, so next, furnace is placed inside the boiler drum. Okay, furnace is placed inside the boiler drum. So it is also called as internally fired boiler. Okay, it is also called as internally fired boiler. 1 minute. Okay, so please join the class before 5 minutes. Okay, so it is, otherwise it is not possible to join. Otherwise, if you want to join anytime, you please send me your mail ID. Okay, so understood, right? Okay. So PPT is visible, right? Visible, right?
Yes, sir. Yes,
Okay.
sir.
Okay, so two pipes are passing throughout the boiler drum. So, and furnace is placed inside the boiler drum. So it is also called as internally fired boiler. Okay, then heat is passing inside a tube. Water is circulated around the tube. So it is also called as what? Fire tube boiler. Why? Because heat is passing inside the tube, water is passing outside the tube. Heat transfer take place between inside to outside. Okay, so here total two side channel and one bottom channel is there. So initially furnace will be producing heat. That heat will be passing throughout the drum. Okay, through this pipe. Okay, through this pipe it is moving throughout the drum. So heat transfer take place between pipe to water. Okay, pipe to water, so that the water gets into heated, slowly converting into vapor form. That vapor form of steam will be collected at the top of the drum. Then that heat will be moving downward direction. That heat will be moving in downward direction. So bottom level of water in the drum gets into heated. Then same heat will be passing to the two side channel. Then heat will be passing to the side channel. You can observe in a top view of the boiler structure. Okay, then it is passing to the side channel. So side portion of the boiler gets into heated. So all around the boiler drum water gets into heated, then slowly converting into vapor form. That vapor form will be collected at the top of the drum. Then it is moving to the turbine blade through the through steam stop wall. Okay, with the help of steam stop wall it will be moving to the turbine blade. Okay, this is the working principle of Lancashire boiler. Okay, so here it is also called as fire tube boiler. Why? Because heat is passing inside a tube, water is circulated around the tube, and internally fired boiler. Okay, internally fired boiler. So heat is passing throughout the boiler drum, so that all the water, whatever water will be present in the drum, that will be gets into heated and converting into vapor form. So that vapor form is nothing but wet steam. Then it is passing to the superheater. So there superheater, it is converting from dry steam wet steam into dry steam. Dry steam is nothing but pure form of steam. There is no water content here. Okay, then that pure form of steam is moving to the turbine through steam stop wall. Okay, this is the working principle of Lancashire boiler. So next, please go through the difference between water tube boiler as well as fire tube boiler. It is there in the notes. Okay, please refer. So I already shared the notes. Those who are not joined to the Google Classroom, please join today itself. Okay. So next we'll see the turbines. So I already explained what is that turbine. Can you tell me what is the turbine? Anyone? Turbine means what? What is the use of turbine? Anyone? Turbine is a device which is used to convert kinetic energy of water into mechanical energy. Kinetic energy of water into mechanical energy. Okay, so hydraulic or water turbines are a machine which converts kinetic and potential energy possessed by the water into the mechanical rotary motion or power. These are further coupled to the electric generator to produce electrical power. So that is called as water turbines. So water is used as a medium for the to produce power. So it is name given as water turbine. So initially water is stored in a dam. Okay, initially water is stored in a dam. That stored energy is called as potential energy. Stored energy is called as potential energy. So water is moving in a dam through the penstoke. That moving energy is called as kinetic energy. Moving energy is called as kinetic energy. That kinetic energy having some pressure. Because of that pressure, it is directly hitting to that pressure is impinging on the blades. Because of that, blade is start to rotating. Okay, blade is start to rotating. That moving energy is called as kinetic energy. So because of that impinging motion or hitting motion to the blades, it is start to rotating. Okay, it is start to rotating. So that rotation energy is called as mechanical energy. So turbine is a device which is used to convert kinetic energy to mechanical energy. Mechanical energy. So then that blade is connected to the shaft. Shaft is coupled to the generator. So with the help of generator, you will get which energy? Electrical energy. So generator is a device which is used to convert mechanical energy to electrical energy. So classification of turbines. Two types of turbine is there. One is impulse turbine as well as reaction turbine. Okay, impulse turbine as well as reaction turbine. So impulse turbine is nothing but direct motion. Okay, is nothing but impinging acting to the blade. Okay, water is directly hitting to the blade, so that is called as impulse turbine. Okay, impulsive force acting to the blade. Impulsive force is acting to the blade, so it is called as impulse turbine. Okay, so water is directly hitting to the blade, that is called as impulse turbine. So reaction turbine is nothing but reactive force is acting to the blade. Water is not directly hitting to the blade, indirectly water is hitting to the blade, that is called as reaction turbine. Impulse turbine is nothing but water is directly hitting to the blade. Reaction turbine is nothing but water is indirectly hitting to the blade. Reactive force is acting to the blade, that is called as reaction turbine. This is a basic definition of impulse turbine as well as reaction turbine. So there, fixed blade as well as moving blade, two varieties of blade is there. That is not there in your syllabus. Okay, you just remember the fixed blade is nothing but guide blades. Moving blade is nothing but rotational blade. Okay, moving blade is nothing but rotational blade. Fixed blade is nothing but guide blade. You just remember these two things. This two is enough for you. Otherwise, varieties of blades arrangement is there. That is velocity based arrangement, pressure based arrangement, Curtis turbines blade arrangement. That different blade arrangement is there. That is not there for your syllabus, in your syllabus. Okay, so you just remember fixed blade is nothing but guide blade. Moving blade is nothing but rotational blade. Next, we'll see the classification of water turbines. So based on the action of the flow of water, it is classified into two types: impulse turbine as well as reaction turbine. So can you tell me what is that impulse turbine? Anyone? Anyone? Please tell me what is that impulse turbine? Hmm. Navya, Akash.
Yes, sir.
What is that impulse turbine?
Direct turbine.
Direct. Akash. So what is that impulse turbine? Aditya. Aditya Shetty.
Yes, sir.
Okay, can you explain impulse turbine means what? Hmm. What is that impulse turbine? Impulse. Impulse is nothing but direct, impulsive force acting to the blade. So water is directly hitting to the blade. That is called as impulse turbine. Water is directly hitting to the blade. So it is called as impulse turbine. Example for impulse turbine is Pelton wheel. Next one is reaction turbine. Reaction turbine is nothing but reactive forces acting to the blade. Reactive forces acting to the blade. So it is called a reaction turbine. Two types of turbine is there. That is Francis turbine as well as Kaplan turbine. Okay, these two turbine. So this is nothing but the scientist name. Francis scientist invented this type of turbine. So it is name given as Francis turbine. Next, this is Kaplan. This is also same thing. Pelton scientist invented this type of turbine. Okay, so water is directly hitting to the blade. So the disadvantages of this Pelton wheel is to high head is required. Head is nothing but high level of water is required. That is the disadvantages of Pelton turbine. Okay, reaction turbine. So medium as well as low head is enough. Okay, medium as well as low head of water level is enough. Head is nothing but level of water. Low level of or medium level of water is enough for Francis as well as Kaplan turbine. So next, based on the head available, so low head turbine, medium head turbine, and high head turbine. Low head is nothing but so very low, up to 10-meter height is enough to produce power. That is example is Kaplan turbine. Next, medium head is nothing but 10 to 50-meter height is enough for producing power. That is Francis turbine. Next, max more than 50-meter height is required. That is nothing but not more than 50 meter, more than 100 meter itself. Okay, more than 100-meter height is required for Pelton turbine. Okay, so it is classified into three types: low head, medium head, as well as high head turbine. So next, based on the direction of the flow of water with respect to the runner, tangential flow turbine. Tangential flow turbine is nothing but water is flowing in tangential direction of the runner. Okay, tangential direction of the runner. So to the circumference of the circle. Okay, so water is flowing in tangential direction to the circumference of the runner circle. Okay, runner circle, that is called as tangential flow turbine. So Pelton turbine is a good example for tangential flow turbine. Okay, so next, it is also Pelton turbine is also called as tangential flow turbine. Next one is the radial flow turbine. So water is entering into the blade in radial direction. Radial is nothing but perpendicular direction. So water is entering in perpendicular direction. So it is name given as the radial flow turbine. Third one is axial flow turbine. So water is entering in axial flow. Okay, water is entering in parallel direction to the rotation of the rotor. Okay, rotation of the runner blade. Okay, so that is called as axial flow. Axial is nothing but parallel direction, radial is nothing but perpendicular direction, tangential is nothing but tangential direction. So that is to the circumference of the runner blade. Okay, circumference of the runner circle. okay, runner circle. Okay, so this is classified into three types based on the direction of the flow of water. This is a classification of water turbine. This is a classification of water turbine. Next, we'll see one by one. So prime mover, so what is that? Prime mover, prime mover is a self-moving devices which converts the available natural source of energy into mechanical energy of motion to drive the other motion. So it is nothing but self-moving so devices. Prime mover is nothing but starting trouble. Sometime turbine starting trouble may be there, so it will just giving some kind of energy to starting process. That is called as prime mover process. Okay, prime mover is a self-moving devices which converts available natural source of energy into mechanical energy, so that turbine is start to rotating. Mechanical energy is nothing but rotation of the turbine blade. Natural source of energy is nothing but water or initial some kind of energy is utilized this prime mover and start rotation of this turbine blade. Okay, so that is called as prime mover. Next, impulse turbine. Okay, so impulse turbine, so example for impulse turbine is Pelton wheel. Okay, example for Pelton impulse turbine is Pelton wheel. Next, it is also called as tangential flow turbine. It is also called as tangential flow turbine. So here you can observe the water is flowing in tangential direction of the runner blade. Okay, tangential direction of the runner blade, and water is directly hitting to the blade. Okay, here water is directly hitting to the blade. So it is also called as impulse turbine, Pelton wheel turbine, or tangential flow turbine. In the sometime in the exam they may ask any name. Okay, tangential flow turbine, impulse turbine, or Pelton wheel turbine. Okay, please remember. Okay, so next, you tell me, so how many parts is there in this sketch? How many parts is there? You just tell me. Anyone? Parts of this impulse turbine. What are the parts?
Eight.
Eight parts.
Eight.
Okay.
8 parts.
Okay, 8 parts. One is needle,
8
nozzle,
parts, sir.
Pelton cups, Pelton wheel, and pump casing, and discharge water. That is called as draft tube. Okay, next the Pelton cups. Okay, so total 8 parts. Okay, no problem. So this is called as penstoke. Okay, this is called as penstoke. So this is connected to the dam. Okay, this is connected to the dam. Okay, here in the sketch here shown below, actually it was upward direction. So it is penstoke is connected to the dam. Understood? Initially water is stored in a dam. Okay, initially water is stored in a dam, so that type of energy is called as what? Potential energy. Water is stored in a dam, that is called as potential energy. That is called as potential energy. So water is moving from the dam. Okay, water is moving from the dam, so that is called as what? Which energy? So water is moving from the dam through this penstoke. Okay, through this penstoke, so it is called as what? Tell me. So it is called as what? So initially water is stored in a dam. Then water is moving through this penstoke. So moving energy is called as what?
Kinetic energy.
Good.
Kinetic
Kinetic energy. Okay. Then that kinetic energy is having some pressure. Okay. So pressure will be further increases with the help of this nozzle. Okay. Further will be increases with the help of nozzle. Then it is come outside from the nozzle and hit to the blade. So because of that, blade is start to rotating. Okay, so now we'll see the parts. Okay, so Pelton cups, this is the Pelton cups shape. Okay, Pelton cup shape, two cups are arranged here, and water is directly hitting to the middle of the cup. Okay, water is directly hitting to the middle of the cup. Then it is after impinging, water will be discharged. Okay, water will be discharged, and discharging water will be moving through this draft tube. Okay, through this draft tube. Understood? So in the draft tube, pressure will be decreases. So area will be increases. In a draft tube, next sketch I will show you how the area will be increases. So area increases is nothing but what happened pressure. So pressure is equal to force by area. So pressure is inversely proportional to area. So area increases is nothing but what happened pressure decreases. Okay, pressure decreases. Okay, area increases is nothing but pressure decreases. So in the draft tube, pressure will be decreases. Why? Because area of the draft tube will be increases. Okay, so next, so this is the runner. So around this runner, number of this type of Pelton cups will be arranged. Okay, so this runner is connected to the shaft. This runner will be connected to the shaft. So shaft is connected to the generator. Okay, so coupled to the generator. So generator will convert that rotational mechanical energy to electrical energy. That electrical energy is uh, moving to the grid. Okay, that electrical energy is moving to the grid. So power is not possible to store anywhere. So whatever power will be generated in the generator, that will be directly go to the grid transformer. Okay, so next, so this is nozzle. So nozzle function is to increase the pressure by reducing the pressure by reducing the area. Okay, by reducing the area. So pressure increases by decreasing the area. Why? Because pressure is inversely proportional to area. Okay, inversely proportional to area. So that pressure decreases, pressure increases by decreasing the area. So further you can increase or decrease the pressure based on this needle wall. Suppose, so this runner blade will be rotating in 1800 rpm. Then if you want to increase the speed of this runner blade, you have to close this wall with the help of this needle wall. Some should be open. So partially close the wall, close the opening with the help of this needle wall. So that what happened, area decreases, pressure is further increases. So that high pressurized water is come outside from the nozzle, then that will be hitting to the turbine blade, and this blade is start to rotating. So further it will be increasing the speed. So pressure increases is nothing but speed is also increases. Pressure increases is nothing but speed of this runner blade is also increases. Next, casing. So casing is the outer part of the turbines. Okay, so this will protect the uh, turbine blade. Okay, it will protect the turbine blade from other extra is nothing but foreign particle or contaminants, impurity. Okay, so this is the parts explanation. Okay, so understood, right? Any doubt in the parts of this Pelton turbine? Now I will explain the operation of this Pelton turbine. So Pelton turbine is also called as impulse turbine. It is also called as tangential flow turbine. Okay, so here water is directly hitting to the blade. Okay, water is directly hitting to the blade. Understood? So next, this is penstoke. So penstoke is connected to the dam. Okay, so initially water is stored in a dam. Then this will be dam water will be open, so that water will be flowing through this penstoke. Okay, that flowing energy is called as kinetic energy. So kinetic energy of water is flowing through this nozzle to the blade. So here area will be reduces, so that pressure what happened, increases. Further you can increase the pressure with the help of this needle wall. So you can increase or decreasing the pressure with the help of this opening. So opening will be controlled by needle wall. Then high pressurized water is come outside from the nozzle, then it is hitting to the moving blade. Okay, it is called as Pelton cups. Because of this water, so turbine blade is start to rotating. After impinging of water to the blade, then water will be discharging through this draft tube. So draft tube also pressure will be further decreases. Why? Because the area of the draft tube is increases, so that pressure is decreases. So discharge water is again goes to the river. Okay, again goes to the river. So this is continuously rotated with the help of this water impinging. So then this runner is connected to the shaft. This shaft is coupled to the generator. So generator will convert mechanical energy to electrical energy. Then it is transfers to the grid. Okay, then it is transfers to the grid. So here water is directly hitting to the blade, so it is also called as impulse turbine. It is called as impulse turbine. So reaction turbine is nothing but reactive force is acting to the blade. Impulse turbine is nothing but impulsive force is acting to the blade. It is nothing but water is directly hitting to the blade. Understood? Any doubt in impulse turbine? Any doubt? Tell me now. Only you just clarify your doubt. Any doubt? Tell me.
No, sir.
Okay. So this is actually the turbine structure. Okay, turbine blades and runner blade. So in this way it will works. Okay, so this is small type of Pelton turbine just for college purpose. Some colleges peoples are make, so that here power transmission take place from runner blade to generator with the help of belt drive. Okay, so belt drive, or else they are directly, usually in the power plant they are directly connected this shaft to this generator, so then power will be produced. So here also nozzle is directly hitting to the blade, because of that blade is start to rotating. Okay,
Welcome to video tutorial channel of me Connors Muller. The Pelton turbine is invented by Lester Allen Pelton in the 1870s. It was the first time the energy in the water converted to power in most efficient manner. Due to its simplicity, the Pelton turbine is the most widely used water turbine in the world. Pelton wheels are the preferred turbine for hydropower, when the available water source has relatively high hydraulic head at low flow rates. The efficiency of this turbines increases with water head. There are 200 megawatt Pelton turbines in operation where water head exceeds 1000 meters. Small Pelton turbines with enough water flow can operate as low as 15-meter water head. Pelton turbine converts the potential energy in water to kinetic energy in the nozzle. Therefore they are impulse-type turbines, which the water strikes the turbine blades with high velocity. For example, for the water head of 1000 meter, the jet velocity coming from the nozzle could be 135 meter per second. Here is an actual wheel of a Pelton turbine which is almost has 2 meter diameter. The spoon-shaped buckets shown in here are bolted to the main discs of the wheel. The buckets are designed in such a way that it splits the water jet into two parts, and each part of the jet make a U-turn in both sides of the wheel. Also notice the tip of the buckets, where a round open section, combined with the groove at the back of the bucket, allows the water to strike the right bucket to produce maximum power. The buckets of these kind turbines could be as much as 150 kilogram. Assuming that the average wheel has 20 buckets, the total weight of the buckets around the rim of the wheel reaches to 3 ton. This makes whole wheel act like a very large flywheel. Since the water head is fixed, the power output of the turbine is controlled by adjusting volumetric rate of water. In the Pelton turbine, this is accomplished by moving the spear, or sometimes called the needle, back and forth by a servo mechanism. Notice that how the diameters of the water jet get smaller or larger depending on the position of the spear. If flow rate goes to 0, the wheel keep turning such a long time due to flywheel effect generated by heavy buckets. To prevent the wheel rotating such a long time, braking flow is used. A small water jet is sent to the back of the buckets to break the rotation of the wheel. If there is sudden power rejection in the system, needle may not have enough time to adjust the position to reduce the amount of water flow. This causes the wheel to begin to turn almost twice the regular rotation speed, which could be dangerous for the operation of the turbine. To prevent this, system senses increased speed and activates deflector mechanism to deflect the water to discharge pipe and prevent the turbine from damage. We encourage you to subscribe to our channel.
Okay, next one is reaction turbine. So reaction turbine is nothing but reactive forces acting to the blade. Okay, so I already mentioned one is fixed blade and moving blade in the reaction turbine. So in impulse turbine, so fixed blade is act as nozzle, and the moving blade is act as that bucket type of Pelton bucket. Okay, runner bucket. So that is moving blade. So here fixed blade as well as moving blade is there. So fixed blade is act as this guide blades. Okay, and moving blade is this one. Okay, so moving blade is connected to the runner blade, and fixed blade is nothing but guide blades. Okay, so it will helps to guide the flow of water into the runner blade. Okay, it will helps to guide the flow of water into the runner blade. So here water is not directly hitting to the blade. Okay, water is not directly hitting to the blade because of that increasing velocity. So that increased velocity water, so water will be discharging through in increased velocity. Because of that water is start to rotating. So water is start to rotating. Initially that water is hitting to the casing part. Okay, this is casing, so it will protect the turbine part. Okay, it will protect the turbine part. This is the outer part is called as casing. Next, this is inlet. Okay, inlet. So here medium head of water level is enough for Francis turbine, and this is guide blades. So it will helps to guide the flow of water to the blade. So blades are in vertical direction to the runner. Okay, blades are vertical direction to the runner. So and water will be entering in radial direction. So it is also called as radial flow turbine. So water is entering in radial direction. Radial is nothing but perpendicular direction of the blades. Okay, perpendicular direction of the blades. So here arrow mark indicates that water will be entering in radial direction. So you can adjust this guide blades. Okay, this is fixed blade. Adjust the guide blade. This guide blade function is to control the flow of water to the blades. Control the flow of water to the blade. Guide, it will helps to guide the flow of water. Okay, guide the flow of water. So this is guide blade and guide wheel. So this is guide wheel, just giving support to all of the guide blade. And spiral casing. So spiral casing is outside part of the turbine. So the you just observe here the casing size is increased, here goes on decreasing. So decreasing is nothing but area decreases, pressure is increases. So to increasing the pressure, so with the help of this casing, so casing structure. So here area is more, and here onwards area is less. Why? Because it will helps to increase the pressure. Okay, increase the pressure. Next, runner blade. So runner blade are in vertical direction to the runner. Okay, so attached to the blade, attached to the shaft. Okay, runner blade is in vertical direction, which is attached to the runner shaft. Okay, next, the draft tube. You can observe the draft tube structure. Here very less area, and here onwards area increases. So what purpose we are increasing the area? So area increases is nothing but pressure is decreases. Why? Because pressure is inversely proportional to area. So pressure decreases is nothing but area increases. Here draft tube is mainly, so once the water is hit to the blade, then water will be discharging through this draft tube. Okay, once the water will be hit to the blade, then the water will be discharging through this draft tube. Okay, understood? So this is the working principle. So here initially water will be coming from the penstoke. So low medium head of water is enough. Head is nothing but level of water. So medium head of water is enough for this Francis turbine. So water is coming. So then water is initially hitting to the casing. So here casing structure will be area will be reduces, so that pressure will be increases. Then increased pressure is moving to the blade through these guide blades. So guide blades adjust, you can adjust the flow control. It is act as a flow control of water. Then water will be moving to the blade and hit to the blades. So water is hitting in radial direction and leaving in axial direction. In the Francis turbine, water is moving to the radial direction and hit to the blade. So water is impinging on radial direction. So then it is leaving in axial direction. So once it is hit to the blade, then it is leaving in axial direction. Okay, so that reaction force, that is nothing but reaction force. So that velocity of leaving water is very high, and it is moving through this draft tube. So draft tube area is higher, so that pressure is decreases. So decrease the pressure is again goes to the river. Okay, so this is the working principle of Francis turbine. Understood? So any doubt? Francis turbine. So this is comes under category of reaction turbine. Reactive force. Water is not directly hitting to the blade. So first it is hitting to the casing, then reactive force is acting to the blade. So here in Francis turbine, water is moving in perpendicular direction. Okay, any doubt? Tell me. Any doubt in Francis turbine?
No, sir.
Okay. So this is actually the sketch of Francis turbine. So blade is arranged like this. Okay, so blade is arranged like this, and this blade is connected to the shaft. Okay, so then this is called as draft tube, discharging water through this draft tube, and this is water entering in this direction. So then it is moving throughout the casing, and casing structure is decreasing the decreases, so that pressure is increases. Then water is entering in perpendicular direction and hit to the blade. Okay, then it is leaving in axial direction. Axial is nothing but parallel to the shaft direction. Okay, parallel to the shaft direction.
Francis turbines are the most preferred hydraulic turbines. It contributes about 60% of the global hydropower capacity, mainly because it can work efficiently under a wide range of operating conditions. Most important part of Francis turbine is its runner. It is fitted with a collection of complex shaped blades. In runner, water is entered radially and leaves axially. During the course of flow, water glides over runner blades. Francis turbine blades are specially shaped. You can note that blades are having thin airfoil cross-section. So when water flows over it, a low pressure will be produced on one side and high pressure on the other side. This will result in a lift force. You can also note one more peculiar thing about the blade. It is having a bucket kind of shape towards the outlet. So water will hit and produce an impulse force before leaving the runner. Both impulse force and lift force will make the runner rotate. So Francis turbine is not a pure reaction turbine. A portion of force comes from impulse action also. Thus, as water flows over runner blades, both its kinetic and pressure energy will come down. Since flow is entering radially and leaves axially, they are also called mixed flow turbine. Runner is connected to generator via a shaft for electricity production. This arrangement is fitted inside a spiral casing. Flow is entered via an inlet nozzle. Flow rate of water will get reduced along length of casing since water is drawn into the runner. But decreasing area of spiral casing will make sure that flow is entered to runner region almost at uniform velocity. Stay vanes and guide vanes are fitted at entrance of runner. The basic purpose of them is to convert one part of pressure energy to kinetic energy. Flow which is coming from the casing meets stay vanes, they are fixed. Stay vanes steers the flow towards the runner section. Thus it reduces swirl of inlet flow. Demand for power may vary over time. The guide vane mechanism is used to control water flow rate and make sure that power production is synchronized with power demand. Apart from controlling flow rate, guide vanes also control flow angle to inlet portion of runner blade. Thus, guide vanes make sure that inlet flow angle is at optimum angle of attack for maximum power extraction from fluid. Low pressure at exit side of turbine may cause serious problems of cavitation. So a carefully designed draft tube is fitted at exit side to discharge the fluid out. Draft tube will transform velocity head to static head due to its increasing area and will reduce effect of cavitation. Hope you had a nice session on working of Francis turbines. Thank you.
I hope all of you understood the working principle of Francis turbine. So this is the sketch of Francis turbine. So front view. So this is a blade arrangement of Francis turbine. So next one is Kaplan turbine. It is also called as propeller turbine. So that turbine we'll see in the next class. So today's class we'll discuss about two types of turbines. What are those? One is impulse turbine as well as impulse turbine is also called as Pelton turbine. The second one is Francis turbine. Okay, Francis turbine. So in reaction turbine, two types of turbine is there. Example for reaction turbine is two types of turbine is there. So what are those?
Francis and Kaplan.
Okay, Francis as well as Kaplan turbine. Okay, so these two turbines. So next, some more topic is there in this module. One is pump. Two types of pump is there, and the classification of pump and the terminology of pumps. Okay, next cavitation and priming. Okay, these two topic is there in this module along with the Kaplan turbine. So within two classes we can finish this module. Okay, so easy, right? Is there any difficulty in this module? Any difficulty? Tell me.
No,
Any
sir.
difficulty? Okay. Mm. So what is the strength in the class? Strength of the class is how much?
45, sir.
45. Okay. Okay. So, but most of them are not joining. So only 31 students are there. Okay. So, okay, please inform to everyone to join. Okay. So attendance will be considered. Okay. So automatically attendance will be considered that with the help of that software. Okay. So please inform to everyone. Okay. Who is CR? CR of the class? CR.
Me, sir.
Okay. So please inform. Okay. Please inform to everyone. Okay. Thank you. Have a nice day. We'll see in the next class. Okay. Remaining portion.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Okay,
sir.
thank you. Thank
Thank you,
you.
sir.
Thank you.